the previous video, we saw what does simplifying radical expression mean. So a radical looks something like this, and the number in the pocket is called index, and the one inside is called radicand. Radicand and index. So if the index is missing, there is a 2 in there. It's a square root, and the number in the pocket is 2. So this means we're looking for what times what gives you 64. That would be 8. And to make our life easy, we can break it. We can do the prime factorization of 64 and look for pairs of two 2's inside because the number in the pocket is 2. If the number in pocket is 3, we want the groups of 3 2's inside. So there's 2 groups of 3 2's inside, so 2 2's come out, and I get a 4. If the number in the pocket is 4, we're looking for groups of 4. You have to have 4 2's inside to be able to bring one out. If the number in the pocket is 5, you have to have 5 2's inside to be able to bring one out. 5 of the same numbers inside. It doesn't have to be 2, because if 64 is a different number, then you would have different numbers in there. If 6 is in the pocket, then you have to have groups of 6 things inside to be able to bring one out. Okay, let's look at some more examples of simplifying radical expressions. We are going to look at the product rule and the quotient rule of radical expressions. To simplify a radical expression, or we say the radical expression is in the simplest form, when as many powers as possible are pulled out of the radical. That means the power inside, the exponent inside the radical should be smaller than the index. The radicand does not contain any factors that have higher power than the index. Okay, the index of the radical is as low as possible, and there's no repeated variables inside the radicals. There are no radicals in the denominator. So these are the 3 conditions that must happen for us to be able to say the radical is simplified. Product property of radical says as long as the index is same, so this is the condition, the index must be same. So as long as the index is same, you can combine the 2 radicals into one and write it as a product. You can also do backwards. You can also break a radical into 2 separate radicals with the same index. And same thing for the quotient rule of radicals. You can write it as a single quotient, single fraction inside the radical, or you can separate into 2 fractions, one radical fraction in the one radical numerator, one radical denominator, as long as the index is same. Let's see some examples. So simplify each of the radical expressions. Assume the variables are positive real numbers. Remember, we talked about if the variables are not just positive real numbers, if variables can be positive or negative, we got to worry about absolute value signs, because we want to make sure answer to a square root or any even root is positive only. So we don't have that worry here because we are told variables are positive real numbers. Okay, so square root of 150, again, we can break it however we want. To make my life easy, I'm going to write it 150 as 25 times 6 because 25 is a perfect square root. So I can write it as square root of 25 times square root of 6. Square root of 25 is 5. So 5 times root 6 is what I'm left with. Notice 5 is not in the pocket. 5 is multiplied with the square root of 6. Okay, you could go another route and you could do prime factorization, which is 5 times 5 times. Well, let me write them in the order. 2 times 3 times 5 times 5. It's a square root, so we have 2 5's inside. 1 5 can come outside, and we don't have 2 2's or 2 3's inside, so they won't come out, and I'll be left with 6 inside. So same answer. Square root of 24, however you want to break it. I'm going to do the, we can do prime factorization. 24 is 8 times 3. Now for each pair of 2 things inside, 1 comes out, and we're left with 2 times 3, 6 is left inside. Okay, because it's a square root, for pair of 2 things inside, 1 will come outside. So here we have y to the 81 power. Do not say the answer will be y to the 9. That would be not correct, because we're not doing square root of 81. We have 81 y's inside. How many y's will come out? So think about 81 y's inside. How many y's will come out? Well, we have talked about, I'm going to express it as y to the 80th power times y. The reason why is the index here is 2. Earlier we talked about that instead of writing 81 y's or 80 y's, we can just go ahead and divide the exponent with the index. That's the power that is going to come out. So 80 divided by 2 is y to the 40th. Y to the 40th comes out, and then times square root of y. This poor y did not have a buddy to come out, so it's stuck inside the radical. Okay. Fourth root of 48. Well, now we're talking about the fourth root. So for 4 things inside, 1 will come out. Let's go ahead and do the prime factorization of 48. 2 times 2 times 2 times 2 times 3. And there's a fourth root. So for 4 things inside, 1 will come out. I can pull a 2 out. Inside would be fourth root of 3. Okay, you could also express it in a slightly different way, which is fourth root of 2 to the 4th power times 3, because we have 4 2's inside. When you divide the index and the exponent, 2 comes out and you have fourth root of 3, same thing. Okay, number 5, we have a square root. Square root of 9, x to the 5th, y to the 7. Let's go ahead and break it. 3 times 3, x to the 5th power. So we have x to the square root here, so we're going to break it as x to the 4 times x, and x to the 7th power, I'll break it as x to the 6 times x. So for pairs of two items inside the radical, 1 can come out. So I'm going to be bringing out a 3 from here. So pull out a 3. I'm going to write it as 3 square, just writing everything with the exponents. You might wonder, why did I break x to the 5th? Because 5 doesn't divide evenly with the 2. 2 is in the pocket. So I'm trying to use, break the 5 so that I have largest multiple of 2 as the exponent for the x here. And I made one more mistake. This is not x, these were the y's. So dividing the exponent and the index, 3 to the 1st power comes out. Dividing the exponent and the index, x to the 2nd power comes out. Y to the 6th divided by 2 is 3. Y to the 3rd power comes out. And inside the square root, we are left with this x and this y. This x and y, they did not have buddies to come out, because remember, you have to have you have to have 2 pairs of 2 inside to be able to bring 1 out. So that's what we're left with now. That's a simplified form of this radical. 3 root 8. Let's go ahead and break 8. 8 is 2 to the 2nd power times 2. Or you can say 2 times 2 times 2. And we can see we have, for these 2 2's inside, 1 2 will come outside. The 2 that comes outside will multiply with 3 outside in the front already. 3 is the coefficient here. 3 times 2 is 6. Root 2 is what we are left with. That's the simplified form of this radical. Okay, next we have square root of 75 z to the 2nd power. Now you can either do prime factorization, or you can say, well, I know 25 times 3 is 75, and 25 is a perfect square, so you can break it this way. We can say this is going to be square root of 25. I can pull that out, which is going to be 5. And I have 2 z's inside. 1 z comes out, and square root of 3 in there. 5z root 3. So 5z root 3 is the simplified form of this radical. Next, we have cube root of 16a squared, b to the 3rd, c to the 5, d to the 7. The reason why I break the exponents is because, let's just go ahead and write 16 is 2 to the 4th power. We have a squared, b to the 3rd power, c to the 5th, d to the 7th. Now my index is 3. I want to have the exponents inside that are multiples of 3. Well, instead of writing 2 to the 4th, I'm going to write it as 2 to the 3rd times 2. Because exponents get added, and it would be same thing as 2 to the 4th power. A square, I really cannot write 2 as a multiple of 3, so leave it alone. B to the 3rd power, 3, that's already, the exponent is already a multiple of 3, so that's good. C to the 5th power, I'm going to write it as c squared times c to the 3rd, because exponents add up, so it's equivalent to c to the 5th power. And d to the 7th, I'm going to write it as d to the 6th times d to the 1st power. And again, don't forget the number in the pocket is 3. Now I'm going to be dividing the exponents with the index. So 3 divided by 3 is 1. 2 to the 1st power comes out. This 2 is left alone inside because 1 doesn't divide evenly with 3. And same thing with the a square left inside. Again, for the b, 3 divided by 3, this simply means we have 3 b's inside. And we have the index as 3. So for 3 b's inside, 1 b will come out. So b comes out. 1 c comes out as well. I need the eraser, smaller one. Yeah. So c to the 3rd power will divide 3 with the 3. 1c comes out. And d to the 6th power, 6 divided by 3 is 2. D to the 2nd power comes out. So let's see what are we left with inside. We are left with a 2. Don't forget 3 in the pocket. So this is just the coefficient in the front. And then we have the radical 3 in the pocket. 2 is left inside. A square is left. And c square and d is left. So that's going to be the simplified radical here. Let's look at, we have 2 more examples. Negative square root of 32, a to the 8, b to the 7. Now the number in the pocket is 2. When you don't see a number in the pocket, then there's a 2 in the front. The negative simply is going to stay in the front. It's like negative 1 times something. That's what it is. The negative 1 is the coefficient here. So 32 is 2 to the 5th power. I'm going to break it as 2 to the 4th power times 2. 8 is already a multiple of 2. And I'm going to break b to the 7th as b to the 6th times b. So let's see, what can I pull out? 2 to the 4th. 4 divided by 2 is 2, so 2 to the 2nd power will come out. This poor 2 will be stuck inside. 8 divided by 2 is 4, a to the 4th power comes out. 6 divided by 2 is 3, b to the 3rd power comes out, and this poor b is stuck inside. So all I'm left with inside is 2b, and outside the coefficient I can simplify a little. That's negative 4, a to the 4, b to the 3rd, 2b. This negative is not getting squared, so don't make it positive, okay? It's just like negative 1 times something. This is like negative 1 times this entire expression. All right, let's check out the next example. 4th root of 32, x to the 12, y to the 5th. Now my number in the pocket is 4. My goal is to have the exponents inside, which are multiples of 4. So I'm going to write it as 2 to the 4 times 2. 12 is already a multiple of 4. And y to the 4 times y will make y to the 5th. And there's a 4 in the pocket. Let's go ahead and start dividing the exponent and the index. So 2 to the 4th power, 4 divided by 4 is 1. That means 2 to the 1st power comes out. 12 divided by 4 is 3. X to the 3rd power comes out. 4 divided by 4 is 1. So y to the 1st power comes out. This poor 2 and the poor y are stuck inside the radical. They didn't have enough buddies to come out. So 2x to the 3rd y, 4th root of 2y is what we're left with. Number 11, we have 2 cube roots that we are trying to multiply. We've talked about that we can multiply as long as, we've talked about the multiplication rule in the beginning here, that as long as the index is same, you can either multiply and write as a product, or you can break a product and write as 2. So I'm going to write it as one single radical, 18 times 6 inside. So let's go ahead and break the 18 times 6. 6 is 2 times 3, and 18 is 2 times 3 times 3. Now, it's a cube root. For 3 things inside, 1 will come out. I have 3 3s inside, 1 3 will come out. I don't have enough 2s inside to be able to bring 1 out. So 2 times 2, 4 is stuck inside, and the 3 goes in the pocket, the cube root of 4. Okay, next example. Now the 2 in the front is a coefficient. It's not the number in the pocket, so treat it like a coefficient. And I'm going to write it as a single cube root of 9 x squared times 3x squared. 2 times cube root. 9 is 3 times 3, and x times x, 3 times x times x. So let's see, do I have pairs of 3 3s inside? Yeah, looks like I do have 3 3s inside. So 1 3 comes out. And I also have 3 x's inside. 1 x comes out. 1 x is left alone inside because there were 4 total x's. So it turns out to be 6x cube root of x. That's all we are left with here in this case. That was number 12. Here's number 13. Again, the same thing. Because it's a fourth root, I will need to have pair of 4 things inside. So I'm just writing the numbers closer. All right. So we need to have pairs of 4 things inside to be able to bring one out. I'm going to break the 9. 9 is 3 times 3. And 12 is 2 times 3 times 3. And I have, how many m's do I have? I do have total 5 m's and total 10 n's. Okay, now just rewriting it slightly differently so that I can see, well, there's 4 3's inside, I can pull one out. Because there's 4 3's inside, I can pull 1 3 out. And the poor 2 is stuck inside because it did not have enough buddies to come out. Let's see now. 3 times 3 is 9. I think that does not look right. 3 times 3 times 2 is not 12, so that's not right. 2 times 2 times 3 is 12. Okay, so here's a bit trouble. So something, I did not do the factorization correctly for 12, but now I fixed it. Let's check. I don't have 4 3's or 4 2's inside to be able to pull one out. So that means they're just going to be stuck inside. 3 times 3 times 2 times 2 times 3, that would be 9. 9 times 4, 36, 108. That will be 108. And I have 5 m's inside. I can pull 1 m out and 1 m will be stuck inside because I'm looking for pairs of 4 m's. I have 10 n's inside. I would be able to pull out 2 n's and 2 n's will be stuck inside. So mn squared, 4th root of 108 mn squared is what I'm left with. The next one, number 4, I'm gonna leave it up to you to try. Number 15, we can write it as a single square root, or we can write them as 2 separate square roots in the numerator and denominator. Because the bottom is a perfect square root already, so I'm going to pull the 7 out. Let's go ahead and break 24. However you want to break 24. And so 24 is 12 times 2, 2 times, or 6 times 4. That's 24. 8 times 3. Any way you want to break it. For 2 2's inside, 1 2 comes out. We have square root of 6 left inside. And square root of 49 is 7 in the denominator. Let's look at number 16. I have 2 separate square roots. I'm going to write it as a single square root. 45y to the 5th over 5y. Let's go ahead and simplify. 5 and 45 divides, and I would have 9y to the 4th. Now, square root of 9y to the 4th will be 3y squared. Next example, number 17. Again, I have a 4th root in the numerator and 4th root in the denominator. I'm going to write it as a single fraction, 48 divided by 3, which is going to be 4th root of 16. And 4th root of 16 is 2, because 2 times 2 times 2 times 2. For 4 2's inside, I can pull one out, and that's going to be equal to 10. Okay, these are the 4 problems. I'm going to leave them for you to try. Once you're done trying, check with me during office hours for the solutions.